All right, so the first thing that you need to know about the derivative function is this idea behind the tangent line, problem. It's basically like where all of, calculus, you know, is said to kind of have been, built from. This idea of this, function that's, that's curved. And unlike, oh, well, I don't know what's going on with this pen. It's dying. Oh, no. Unlike in algebra or up to now in your math live, like we haven't really had a way to figure out how curved lines, behave. Linear equations or straight lines, very simple. We had a very straight up slope. But if we want to find the rate of change of this, of this function right here, let's call it f of x. What we have to do is, pick a point on the line and make a tangent line. And from there, we get an estimate of how this function is changing or what the rate of change is at this point, because it's changing. The way it's changing is changing. The rate of change of this line is changing. It's not constant. Now, the problem though is if you only have one point, how are you going to be able to get a slope? So if you remember how we went over at the start of this chapter, what we do is we make a secant line that goes through this point as well. That's and another point, let's say up there, for example, another point on the graph of the function f of x. We have this secant line. Now, since the secant line has 2 points, we can find the slope of the secant line, and it'll give us a rough estimate of the slope or rate of change of the tangent line. Now, obviously, it's not going to be perfect, but if we want to make it more accurate, we would want to bring this point closer to this point. And let's call this point, let's give this point on, let's give it coordinates a, f of a. We want to bring this point over here as close as we can to this point, because that's going to make the slope of this line be very, very close to the slope of this line. This is the idea of the limit. It gets infinitely close. And what we're going to be a little clever here so we can understand this notation. Let's remember how we use a slope triangle to kind of get when we first learned about rate of change or slope. So let's look at the slope triangle. We're going up this much and to the side this much. So let's call the width of this, or the base of this triangle, or this length here. Let's call that h. Let's call that width h. So that means the coordinate of this point here is going to be a plus h, which means the y coordinate will be f of a plus h. So if you want to find the slope of the secant line, you just use your typical slope formula, right? The y2 minus y1 over x2 minus x1. But we want to look at it as this is our y2, let's call that. This is our y1, and this is our x1, and this is our no, this is our this is I goofed off there. I was actually checking to see if you guys will catch that before I do. That's x2, that's y2, of course, and this is x1, and this is going to be y1. And so, slope is, y2 minus y1 over x2 minus x1, but let's use this. Let's make it f of a plus h minus f of a all over a plus h minus a. Simplifying this, the top keeps it at f of a plus h minus f of a. The a's cancel in the denominators. All you have is h in the denominator. And now this is also known as your difference quotient, or the definition for the equation of a derivative. Because, well, we have to add one more thing technically, which I'm going to show you right now. Remember, we want to get this width, or this, this point as close to this point as possible. So that means you want to make h very, very small. So we write this as the limit as h goes to 0. Now it's known as the derivative, so we define it as f prime of x. The instantaneous rate of change. That's a formal definition. Make sure you understand that. Usually we'll have a conceptual question on it, but as you can see, these take a while to kind of work through. But make sure you understand that because it's really key for the rest of the course. Anyways, now let's get to like all the quick rules and stuff. Before though, you're usually gonna have to make sure you understand where derivatives cannot exist. And I like to break this down into kind of like two simple cases. So derivatives are going to fail to exist when you have something like this. Your graph is looking like, kind of has like a sharp point. Sharp point, or like a cusp, I guess a cusp. So f prime of x does not exist here. And that's because if you were going to take the slope from the left, the tangent line would be something like that, right? But the slope from the right would be like this. And these are obviously not equal. So the derivative wouldn't work mathematically speaking. So the derivatives fail to exist at like graphs have like sharp points like that. They also fail to exist on graphs with vertical tangent line. So something like this. At the origin, you would have a vertical tangent line. So f prime of x would not exist there at the origin. That would be like the cubic function, that sort of thing. So know where derivatives fail to exist. Okay, now the fun stuff. Know your derivative rules. This chapter you have to master being able to get a derivative using all these rules. The first one, the power rule, which is basically if you have the derivative of a function, let's say x to the n, so it's written in terms of power, that this would just be equal to the power n times x to the n minus 1. That's your first power rule. First rule for derivatives usually. Next, you have a constant function rule. So if you have a function that's just like a number, we'll call it c. The derivative of that is just 0. Because think about it. If you have a function that's a constant, it's just going to be a horizontal line. Let's say your constant was like 5. And the slope of a horizontal line is just 0. So the derivative of any constant number is 0. Next, we have the constant multiple, which says if you have the derivative of basically some number times a function, let's just say x to the n. Technically, you should write it like this. I guess you should write it like c times f of x. That c don't matter. You just keep that c as a coefficient and you multiply it by the derivative of f of x, whatever that is. Pretty simple, pretty straightforward. Doesn't interfere. Next, sum and difference. This is also pretty common sense, at least I thought. You're just adding two functions. Whoops. Ignore that. It's not a derivative yet. If you have f of x and g of x being added and you're trying to find the derivative, just take the derivatives individually. So this will just be f prime of x plus g prime of x. Next, we got, move this down a little bit. Know your trig derivatives. The main ones you have to know are the cosine, the sine, and the tangent. So know that the derivative of the sine function is the cosine function of x. Know that the derivative of the cosine function of x is the negative sine function of x. And know that the derivative of the tangent of x is the secant squared of x. Those are usually only the ones that come up on like a test. Unless your teacher really wants to, be tough or get you. But it's really just memorization. Of course, you could derive them. You could derive, or you could just memorize them, like the secant. You saw the secant of x, cosecant, cotangent, and your other ones. But usually these are the ones that pop up. I've rarely even seen like sine on the sine function derivative. Well, not the sine. I'm talking about inverse sine. I've never really seen any other ones. on an AP test. But don't hold me to it. But that's just my experience. But just be aware. So next, we want to understand how the derivatives relate to velocity, position, acceleration. So like common kinematics functions. So the derivative of position, and we're talking about with function with respect to time. So S of t is typically position. The derivative of the position function is the velocity function. Because remember, velocity describes how your position changes. So it's the rate of change of position. Now the derivative of the velocity function would be the acceleration function, because the acceleration describes how velocity changes. And those are really the ones you just have to know. They get tricky when you do more integrated, involve like word problems. So beware. Now, no higher. So going from this, no higher order derivatives. So we have, the first derivative, f prime of x. We have, second, f double prime. We can keep on going. Third, fourth, and so forth. Once it gets to the fourth, you usually use like a number like that. And you can also rewrite these, or not rewrite, but rewrite them like this. As you know, you're going to write that dy dx. The second derivative, you would write it though as dy with like a, the bottom. Even though I'm messing up. That you would have like an exponent of 2 there over dy dx. Look at me. Now I'm nervous. So you would write it like this, but no, these are not you know that they're not exponents. That's just the way they write it. So the third order derivative would be like looking like this. And the fourth order, like this. You just know if it randomly pops up on a problem and you don't know what it's talking about. It's really key when you get into differential equations, because you're going to be working with a lot higher order derivatives. But it's just notation, nothing more to it than that. Now, the last couple of rules for derivatives, make sure you know them. These are very useful. You got the product rule. You have like the derivative. You want to find the derivative of, f of x times g of x. This would be equal to the derivative of f of x, f prime of x, times g of x, plus f of x, times g prime of x. Next, we got the quotient rule. You want to find the derivative of f of x over g of x. That would be equal to f prime of x times g of x minus f of x times g prime of x, all over g of x squared. I know there's probably some clever ways to memorize this. I'm not really good at like coming up with mnemonics, but just memorize it somehow. Because you don't want to screw up on something like that. But you could always, find other ways. Anyways, the last one is the chain rule. And this is when you have a function of a function. It's like a composite function. You have like f of g of x. So you have like an inside function in red. For this you would need to take the derivative of g of x and then multiply by the derivative of f of g of x. So f prime of g of x. That's your chain rule. Really practice with these rules, especially chain rule, because it does take some time to catch on to it. That was the hardest one for me. I'm gonna add a link to my practice videos with a ton of derivative problems to this video. So keep an eye out for that, because I'm gonna go over a lot of those so you can be really proficient and master all of them, because this stuff takes a lot of practice. That's all it is to it. And the last main thing in this unit would be the implicit differentiation concept. And again, this is something where it's more about practice. And I'm just going to go over like a simple example, because again, it's a little abstract at first. But it's basically when you have a function, or when you basically when you can't have a function. So when you can't write y strictly in terms of x. So that's usually like for like a circle. Circle is not strictly a function of x because it violates a vertical line test. Let's say you have this y squared plus x squared is equal to 25. You can't strictly solve for y because you don't have a function. So if you want to take the derivative of this still, you would use what's called implicit differentiation, which means that when you take the derivative of y, the y term, you're going to multiply it by dy dx also. So it would look something like this. You would have 2i times dy dx. Take the derivative of x squared as normal, so that would be 2x. The derivative of 25 is 0. Then we just solve for that dy dx. Negative 2x over negative 2y. And so you get x over y. So this stuff, again, is something that you want to practice a lot with because this is actually something that usually will involve all the rules we just went through in some extent. Anyways, there you go. I hope that helps. I did my best to keep it simple and straight to the point, but let me know if you have any questions or if you want me to keep making these types of videos, because I can probably get these going every week for each chapter. But let me know if any feedback, any improvements I can do. And if you like these, give it a like or a thumbs up and subscribe. Thank you.